Hey everybody, and welcome back. So just to remind you, this is coming in on the other side of our winter break, so make sure that you have checked back in on our last lesson just to recap on what we've done, because this is a continuation from that, building up to our next checkpoint. So there is one lesson that was before the break, and then two that are going to be after as part of the checkpoint, and then we had a whole checkpoint before that for radical functions that you just want to make sure you are up to date on before you take our unit test. All right, let's get started. So goal for today, we're going to revisit the laws of exponents. And we touched on that in the last lesson, but we're going to really focus on the majority of the laws today and put them into practice. So to do that, we're going to just simplify expressions with these different laws coming into play. So we're going to use them to get it down to a simpler expression or evaluate it in some way or find out some more information. So the essential questions for today, it's a harder one. What are the laws of exponents? So now this is asking, like, do you know them without having to check your notes? And then could you describe how they work in general? So with like A's, B's, X's, Y's, M's, N's, so just in general. And then also with specific examples. So say like 2 to the power of 3 all raised to the power of 2 is equal to blank. And then you can describe, okay, here's how it works. So in the last video, we talked about just the general form of radical expressions, and then we translated between the two. So how do you go from an exponent of like a half into radical form? Or if you have the fourth root of x to the power of 5, what would that look like with a rational exponent? So if that's like kind of like you're not quite sure, then you need to go back to video 29 and recap on that before you move forward. I would actually stop now and go back and watch that one again before moving forward. It's not a long video, so take the time, go do it. All right, so here's our laws that we're going to be working with today. So the first one is the product of powers property. And this is basically if you have the same base number. So I'm going to go to the algebraic example here. So you've got A as the base number in both cases. 1 is to the power of m, 1 is to the power of n. If they are multiplied, the base number stays the same, so it's still a, and the exponents are added. So if you multiply the same base number, the exponents of that number will add together. The quotient, so same setup, same base number, but this time they're divided. Instead of adding the exponents, you would subtract the denominator from the numerator exponent. So a to the power of m divided by a to the power of n results in a to the power of m minus n. So you would subtract them. Now, obviously, in the situation we have right now, your notes are very accessible to you, but this is something that if you don't know these power properties, you really want to consider memorizing those, making posters, doing flashcards, whatever you need to do to get this stuff in your head, because this is laws for how you manipulate different expressions, which is going to be used throughout your math career. So if you're going up to a higher level after this, you really do want to know your laws of exponents. Power of power properties is kind of that example I was talking about. So if you have a to the power of m, parenthesis to the power of n, so it's a to the power of m all to the power of n. I wish they'd used different letters here. You multiply those exponents, so it'll be a to the power of m times n. The next one, the power of a product property. So if you have two numbers multiplied and they're both raised to an exponent, the exponent distributes to those two numbers. So a times b to the power of m is the same as a to the power of m times b to the power of m. And then power of a quotient property, if you have a fraction, so a numerator and denominator raised to an exponent, the exponent applies to the numerator and the denominator. So very simple, a over b to the power of m is going to be a to the power of m divided by b to the power of m. Now there is one that's not on here that I do want to bring your attention to, and this is if you have a to the power of minus 1, this is the negative exponent property, it is equal to 1 over a to the power of positive 1. So a negative exponent means that it is in fact underneath of a fraction. So another example of this numerically would be 5 to the power of minus 3 is the same as 1 over 5 to the power of 3, which if we were to simplify that is 1 over 125. So a negative exponent puts it underneath of a fraction. So if you have a times b to the power of minus 1. So just the b to the power of minus 1. This would be a over b. So that's just another way of writing it in power of 1, but we know that power of 1 is just one of those things you don't necessarily have to write. So just be aware of that. That's another exponent property that's going to pop up now and again. So the best way to do this is just launch into a bunch of examples, and you can always go back then and watch these again if you come across similar problems. So the first one I'm going to look at is 25 to the power of 3/5 times 25 to the power of 7/5. So this was that first property. They have the same base, 25, and they're multiplied. So we're going to do 25, same base, and then for the exponents, it's going to be 3/5 plus 7/5. So they're going to add together. So 3/5 plus 7/5, they have the same denominator base, so I can add the numerator. So that's going to be 10 over 5, which is 25 to the power of 2. And typically, if you can evaluate it, you should. So 25 to the power of 2 is 625. So sometimes we're looking for this answer, sometimes we're looking for the full evaluation. It just depends on how the question is phrased. All right, so in this one, second property on our table, we're dividing and they have the same base. So this is going to be 8 to the power of 1/3. So the numerator minus the denominator. So that will be 8 to the power of 1/3 minus 2/3, so that's minus 1/3. So now remember, a negative exponent means this is in fact 8 to the power of, 1 over 8 to the power of 1/3. Now the reason why we would go into this step is often the question will say you're not allowed to have negative exponents. So they need to be rational and they need to be positive, is typically what you're going to get told. So if that happens, any negative exponents, you immediately put the number underneath the fraction with 1 on top, unless there's another value that you can use as the numerator. All right, let's take a look at this one. So in this one, we've got a large parenthesis, so that's kind of one of our first concerns. We've got 3 over 2 as that exponent on the outside. Inside, we've got y to the power of 4 over 3 divided by 16, y to the power of 2/3. So the y's I can deal with first. So if we think about this, this is y to the power of 4 over 3, and then y to the power of 2/3 is underneath the fraction, so I can subtract that 2/3. So I'm just talking about the two y values at the moment. So I'm simplifying the y values. This is all over 16 still, and all to the power of 3 over 2. So y to the power of 4/3 minus 2/3 is y to the power of 2/3, all over 16 to the power of 3 over 2. Now remember, an exponent with a fraction will distribute to both parts. So this is going to be y to the power of 2/3, and it's exponent of an exponent, power of a power property. So it's going to be times 3 over 2, and then it's going to be 16 to the power of 3 over 2. So y to the power of 2/3, so they cancel and they cancel, so it just ends up being a y on top. And then 16 to the power of 3 over 2 is, so remember from the last lesson, divided by 2 is square root of 16, so that's 4, and 4 to the power of 3 is 64. So this would simplify to be y over 64. So you may be asked for, like, it's just y over 16 to the power of 3 over 2, but usually we do have to evaluate it if we can. All right, so this one, another case where the exponent is going to distribute. So it's going to go to both terms. So we've got 27 times x to the power of 3/4. So this is going to be 27 to the power of 2/3 times x to the power of 3/4. And since it's an exponent, power of a power property, it's going to be times 2/3. All right, so 27 cube root of 27 is 3, and 3 squared is 9. So we get 9 times x is still going to be there. So we're multiplying fractions, so numerators and denominators multiply, so it's going to be 6 over 12, which is a half. So this is 9x to the power of a half. So the half does not apply to the 9, it just applies to the x. If I had parentheses in here, the half would apply to both. So you do need to be careful when you are answering questions in this unit that you are using your parentheses correctly. All right, take a shot at it. So simplify the expression. All variables positive. Exponents should be positive. So simplified and positive. So if you come out with a negative exponent, I do expect you to put it underneath the fraction. All right, so your first one, 12 to the power of 2/3 times 12 to the power of 4/3, all to the power of 3/2. And your second one, 6 to the power of 1/3 divided by x to the power of 5/3 times y, and then the numerator is also squared. So I want you to try and simplify that out as much as you can. Come back when you're done. Okay, so looking at the first one, base value is the same, so it's going to be 12. We're going to add those exponents, so it's going to be 12. And you could do this in another order. Like you could distribute the exponent first. It doesn't matter. You will get the same answer either way, but I kind of like to tidy up what's inside the parentheses first, and then bring in that extra number. So we got 12 to the power of 2/3 plus 4/3. So that will be 6/3, which is 2. So it's going to be 12 to the power of 2, all to the power of 3/2. Now I could evaluate 12 to the power of 2 at this point and call it 144, but just like noticing here, 2 times 3/2, like the 2's are going to cancel. I can make life a little easier for myself by just leaving it as is for now. So this will be 12 times 3/2. 2's cancel, so this ends up being 12 to the power of 3, which is 144 times 12, which is 1728. All right, so you may be asked for the 12 to the power of 3, you may be asked for the final version. It's always safe to put them both down. All right, number 2, I'd say what I will do here is bring in the squared first, because you can't really go messing with the x's until that squared is taken care of. So we've got 6x, and the 6 is going to be squared, and the 1/3 is also going to be squared, so that 2 is going to distribute to both terms inside, and this is all over x to the power of 5/3y. So on top we get 36, and then that will be x to the power of 2/3 all over x to the power of 5/3 and y. So the x's are being divided. Thinking about it, if it was just x, we would cancel them, but because there's exponents involved, we are going to subtract them. So it's going to be 36 2/3 minus 5/3, and then over y. So that's 36 x to the power of minus 3/3, so minus 1, and then all over y. So now that x to the power of minus 1 needs to go underneath the line, so it's going to be 36 over xy. So x to the power of positive 1 now that it's underneath the line. So this would be that final answer I was looking for. If you give me the x to the power of -1, like you haven't fully simplified it, you will lose some points. All right, so just looking at what the rules are that I'm trying to follow here, we've got radical functions. We're going to be converting those into rational exponents and then simplifying it down using our laws. So simplify the expression by writing it using rational exponents. So that was last lesson. And then use the properties, which is today's lesson. So you're combining everything together and then making sure that it's simplified and positive for the exponents. All right, so looking at that first one, we have x times the cube root of 2y. So that would be x times 2y to the power of 1/3. And then we've got 4x squared y squared all to the power of 1/3. All right, there's a couple of things I can do here. First off, they're both to the power of 1/3, which means that I could technically multiply the 2y and the 4y squared and all that together. So it would look like this. So I've got 2y times 4x squared y squared all to the power of 1/3. Like that works. Because remember, going back to square roots, if we had like square root of 2 times square root of 5, we could write that as square root 10. So that's the same as 2 to the power of a half times 5 to the power of a half. And we're saying, oh, that's 10 to the power of a half. Like, it works that way. So we don't have to worry about like, oh, I've mixed up numbers here that I'm not supposed to. So the cube roots can be combined, basically, is what we're saying. At this point then, let's simplify it. So 2y times y squared, that's going to be a y cubed, and the 2 times 4 can be simplified as well. So I've got 8x squared y cubed all to the power of a third. Now is when I'm going to bring that third in. So I'm going to have x times 8 to the power of a third times x to the power of 2/3 times y to the power of 3/3, which is 1. We're almost done. 8 to the power of a third is 2. X and x to the power of 2/3 can be added together. So what's the exponent here? It's 1. Think of it in terms of thirds. 1 is equal to 3/3. So I can do 3/3 plus 2/3, which is 5/3. So x to the power of 5/3. And then we've got a y at the end. Sometimes how you will see this written is you keep the whole parts out. So that would be 2 x. If I take an x out, there's 2/3 left over. So 2xy, and then it would be the cube root of x squared. Like you put the, if you want the, like the remainder part back into radical form. That'll happen sometimes, like that you'll see this come up. More so like you would see that offered as an answer option. You'd have to see, okay, these two are equivalent to each other, more than me asking you to write it in that way. I'm typically good with you putting into rational exponents and simplifying those rational exponents down as much as possible. Okay, so for next example, we've got square root of 64y, cube root of 64y. Let's get that one going. So that would be 64 to the power of a half over, 64y, and 64y to the power of 2/3. And where I'm getting 2/3 from, 1/3. All right. I would probably distribute at this point. Like I know that 64y is technically the same base, but I would just get the 64 out of there. So 64, square root of 64 is 8. So it's going to be 8 times y to the power of a half. And the cube root of 64 is 4. So 4y to the power of a third. And then 8 divided by 4, that simplifies down to be 2. Now we just have to worry about the y part. So it would be 2y to the power of a half minus a third, because they are divided. So a half minus a third, now you're dealing with fractions that don't have the same base. So you have to get them in the same base, which would be over 6. So this would be 3 minus 2, which is 1/6. So it would be 2y to the power of a sixth. So the half minus a third had to get the common denominator. We should be very confident doing that after our past couple of units, as well as that's an Algebra 1 skill. And then that would be 1/6. So this would be 2 times the 6th root of y if we were going back to radical form. All right, your turn again. Just messing around with these radicals, get them into rational exponent form, and then simplify them down, making sure you have those positive exponents when you're done. Question 1 looks very similar to the last one we just did, except there's an x to the power of 3 in there as well. All right, pause the video, come back when you're done, see how you did. Okay, so we've got square root of x cubed, so that's x to the power of 3 over 2, and then cube root of x cubed, I mean, those technically cancel, so it's x to the power of 1. So that means it's x to the power of 3 over 2 minus 1, and 3 over 2 minus 1 would be 2 over 2, so that would be a half. So this ends up being x to the power of a half, or the square root of x. All right, the next one 16, sixth root of 16 cubed, so it's 16 to the power of 3 over 6, which is a half. And then we've got 4 to the power of 6 over 4, which is 3 over 2. And then 8 to the power of 2/3. Now, this is one you technically could just plug into your calculator. There's no reason why you can't. The only issue is if like you end up with like an exponent of a sixth. That's not going to show up in your calculator. If it's a whole number, it will show. If it's not, you're kind of out of luck. All right, so 16, that simplifies to be a half. So the square root of 16 is 4. 6 over 4 is 3 over 2. So the square root of 4 is 2 to the power of 3 is 8. And then the cube root of 8 is 2, squared is 4. So this does simplify down to be a whole number. So we get what, 16 times 8 is 128. So yeah, that one is one that a calculator would do for you. And sometimes it's just worth plugging it in just to see like, hey, it's numeric, what does it come out to be? And if it's a whole number, fantastic, your job's done. If you're getting like a radical or an irrational decimal, then you do need to go and figure out what those exponents actually are. Okay, there's not much going on here. Like we just kind of talked about this, but say like your roots are bigger than cubes or square roots, like you're into 4th, 5th, 6th roots and so on. So we've got the nth root of AB. You can split that. So we talked about this, like you can split that into its factors. So we did that when we were simplifying radicals before. We split it into its factors. So for example, square root of 50, we were able to say, well, that's square root of 25 times square root of 2. We were able to split it into its factors, which ended up being 5 root 2. Same idea up here. Like if this was the 4th root, you would say, okay, that's the 4th root, 25 times 4th root 2. Like they just keep the same radical. And then same thing when you're dealing with fractions, that you can split the fraction as well. So square root of 25 over 16, you can split it into square root of 25 divided by square root of 16 and then simplify it down. So just make sure you got those two rules added into your list of exponent properties that we want to memorize. All right, so we want to simplify the expression and assume that all variables are positive and rationalize any irrational denominators. Got it. So simplify, we can do that. We've got cube root of 256 x cubed y 7. So this would be 256 x cubed y 7 all to the power of a third. All right, so now 256 to the power of a third, so we can put that in. So 256 power of a third. I just checked my calculator really to see if that is a cube number, which it probably is given the question. Oh, no, it's not. So we got 256. I'm surprised at that, actually. Math. So cube root, by the way, is located on your math button. So 256. All right, so 256 to the power of a third is going to stay as it is. There's nothing else we can do with that. X to the power of a 3 to the power times a third is just 1. And then y to the power of 7 over 3, because 7 times a third. Now, one thing that they are probably going to look for here is that you separate out. So I was talking about this beforehand. It's probably going to come up here. So we would keep the stuff that has whole number exponents, so the x, and then also this y value is y to the power of, so 3 goes into 7 twice, and then you're left over with a third. So sometimes what we do is we take out those whole numbers, and then we say, okay, and that's times 256 y to the power of a third, or even you go back to radical form. So xy squared cube root 256y. So you pull out the whole number stuff. It's kind of like simplifying and then having a remainder. You will be asked to do that sometimes as well. So we want to simplify the expression. We did that. All variables positive, got it. Rationalize any irrational denominators. We didn't have to do that. Okay, so I would be cool with this answer this one's fine. Just be careful that you may be asked at some point to simplify down like that y and call it y squared times cube root of y. And then x to the power of 2, or 256 to the power of a third. If it can be simplified down, we do it. All right, fourth root of 81 over x. So this would be 81 over x to the power of a quarter, or we could say it's the fourth root of 81 over fourth root of x. Like, doesn't really matter which one we do. So does 81 have a fourth root? So what I usually do for fourth root is either the math button, there is an option to do a any number root. I also just like doing 81 to the power of a quarter. So 81 raise it to an exponent, so that's that number over the division sign, 1/4, and it's 3. So this would end up being 3 over x to the power of a quarter, or 3 over the fourth root of x. Like, either of those are acceptable answers. If it wants a rational exponent, then you need to use a quarter. All right, your turn. Take a shot at this and see how it goes. Pause the video, come back, and see how you did. All right, so we got cube root of 216. So I'm just going to do that. I'm going to do it the way that I guess they really want you to do it. So separate out. So cube root of x to the power of 12 times cube root of y to the power of 15. I kind of prefer just going into the rational exponent straight away because it just makes life a little bit simpler. So now we say, okay, what is the cube root of 216? Does it have one? That's 6. Okay, so we got something this time. 6. And then this would be x to the power of 12 over 3, which is x to the power of 4. And then we got y to the power of 15 over 3, which would be y to the power of 5. So 6, x to the power of 4, y to the power of 5 is your final answer. Number 2, we've got fourth root of 16 over fourth root of x to the power of 14. Now I'm going to go for, does 16 have a fourth root? I don't think it does it? So let's see, 16 to the power of 1 over 4. Oh, it does too. Of course it does. So 2. Now, x to the power of, so I'm going to put this into rational exponents because this is 14 over 4, which would be 7 over 2. So it would be 2 over x to the power of 7 over 2. So that's the simplest we can do in rational form. If it went back to radicals, then it would be square root of x to the power of 7. I actually prefer this form here. It tells me more. All right, so your essential questions for today. What are the laws of exponents? Hopefully you can list them all. And then how do they work? What do they do? So power of a power property, power of product property, quotient of a power property, and so on. How do those work? And then what do they do? Don't forget the negative exponent property. We want to make sure we include that one. And then the nth roots for products and quotients. So after today, you should be able to complete the Module 2 folder, Simplifying Radical Expressions. And there's one lesson after this before the unit is over. I'll see you then.